Okay, so in this lesson, we're going to be looking at direct and inverse variations. So it says direct variation describes a directly proportional relationship between two variables. So what that means is when one quantity increases, the other quantity also increases. And then vice versa, when one quantity decreases, then the other one also decreases. Okay, so the direct variation equations belong to linear. So again, if one's increasing, the other one's increasing, and then also decreasing. So if you look over here, that's what it looks like on a graph. So the form of direct variation is y equals k times x. K is going to be your constant of variation. So we're going to be using that when we're looking at direct variations. Now we're going to also talk about inverse variations. Inverse variations describes an inversely proportional relationship between two variables. So what that means is if one quantity is increasing, then the other quantity decreases. And then vice versa. If one of them is decreasing, that the other one increases. An inverse variation equation belongs to the rational function family. Rational looks like this on a graph. Two separate pieces. The reason for that is because the form of it is a rational equation. Y equals k divided by x, where k is your constant of variation. So these two equations right here you're going to need to know. So if it's direct variation, y equals k times x. If it's inverse variation, which means one's increasing, the other one's decreasing, you have inverse variation. So those are the two equations that you're going to need to know. All right, so we're going to do some examples. Use the information provided to write an equation representing the given relationship. So it says x and y vary inversely. There is your key word. If it says inversely, remember you're using y equals k over x. You're going to write an equation to represent the relationship if y equals 6 and x equals 8. So you're going to substitute that in. Y equals 6. We don't know k, which is the constant of variation. X is 8. So I need to find what k equals. So in order to isolate k, I need to multiply both sides by 8. So I would get 48 equals k. Once you find your k, then you're going to plug it back into this equation to write your equation. So k is 48 over x. So there is the equation that we're going to be using in order to do the next section. So once you find k, substitute it into that inverse variation. So we're using the equation to determine the value of y when x is 32. So again, I'm using this. So I don't know y. I know my constant's 48, and I'm dividing it by my x that I'm given. So 48 divided by 32, you could either simplify it to 3 over 2, or you can write it as 1.5. So I'll accept either answer. Okay, so let's try example B. So example B is saying the graph of a function passes through the point 24 1/2, which is x and y. If y varies inversely as x, there's your key word, write a function relating x and y. So we're given x and y just like we were given on example A, but it's in an ordered pair form, which is fine. So we know our equation is going to be y equals k over x because it said inversely. I'm substituting in the y is 1/2 We don't know the k. The x is 24 because we found it from this ordered pair here. So I need to find my k. So I'm going to multiply both sides by 24. And you get k equals 12. Once we find k, remember we need to substitute it back into that inversely equation. So y equals 12 over x would be your equation because it's wanting you to write the equation. Once we find that, then we can use it in order to find the other section of this problem. So now it's saying use the equation to determine the value of y when x is 32. So I'm going to plug in. My constant's 12. My x was given to me. It's 32. So again, you can either reduce the fraction, so that would be 3 over 8, or you can write it as the decimal point 0.375. So there's your y value when x is 32, using that constant of variation. So you're having to read the problem and you're having to look for keywords to know which type of equation you need to use. So part C. The graph of the function passes through the point -12, -9. So again, we're given x and a y. It says if y is directly proportional, keyword is directly, proportional to x, then write an equation relating to your x and y. So directly, remember your equation is y equals k times x. Inversely is k divided by x, so you have to know which one's which. So I'm going to substitute in, so I know my y is -9. I know my x is -12. So I will have to divide both sides by -12. So k is going to equal, that's going to be a positive 3/4, or you can write 0.75. And then plugging back into this, we get y equals, I'm just going to use 3/4 and then x. So again, you can use 0.75 or 3/4. We're using that, so we're using this equation to determine the value of y when x is 32. So I'm going to substitute in. So y equals 3/4 and then x is 32. So 3/4 times 32, that's going to be 8 times 3, so that's going to be 24. So our y equals 24. All right, so again, keywords, make sure checking for inversely, directly. That helps you knowing with what type of equation you need to set up. So last example on this, it says if x and y vary directly, so y equals k times x, y is 52 and x is 4. Write a function to represent the relationship between the two variables. So I'm plugging in y is 52, x is 4, divide by 4, and then you get k equals 52 divided by 4, which is 13. So again, once you find your k, you need to plug it back into that equation. So it should just be y equals 13x. You're using that equation in order to find y when x is 32. So I'm going to substitute in. So y equals 13 times 32, which would equal 416. So there's the y value whenever x is 32. Okay, so this is, again, direct and inverse variation. So let's look at the back. Determine if the phrases below describe direct or inverse variation, write the appropriate equation. So this is a good one to look at keywords. So y varies directly, so this is direct. Remember, direct is y equals k times x. Y is inversely proportional, so that's inverse, which is y equals k over x. X and y vary inversely, that's inverse. Y equals k over x. And then y'all try the next three. So go ahead and try them, and then I will let you know what the answers are. So you can pause the video. Okay, so part D, hopefully you did this. should be direct because of this keyword, y equals k times x. Inversely, inverse, y equals k over x. And directly, y equals k times x. Okay, so again, you're going to have to know which equation to set up. So this next section, we're going to be given some points this time. We're going to distinguish between direct and inverse variation based on the points. So step 1 is to examine the given table, or if you're not given a table, then make a table. You're going to identify the relationship by checking for a constant product or ratio. So product means multiply, and then ratio means your fraction, so divide. So if the ratio of the y, let's go back. If the product of the y and the x is a constant, which means it's the same every time, then that will show us that it's an inverse variation. If the ratio, which is a division, dividing, of y and x is constant, which means it's the same for all of them, the data represents a direct variation. So you're going to use the data to write a function if required. So in order to do that, you're going to select the corresponding variation equation and use 1 point to determine the constant. Okay, so once you have that, you're going to rewrite your function with the correct constant of variation. Okay, so we're going to compare on the table the y and the x. So we're going to, first off, I would just start out with dividing it. So 0.6 divided by 3, 2 divided by 10, and 4.8 divided by 24. So you're just taking the y value, dividing it by the corresponding x to see if there is a constant of variation. So I'm going to have 0.6 divided by 3, which is 0.2. 2 divided by 10, which is 0.2. And 4.8 divided by 24, which is also 0.2. So since all of those are equal, we divided them, which is the ratio. So look back up. It says if the ratio of the y and the x are constant, which it was the same, that's a direct variation. So we're going to have direct. And then our direct variation is, remember, direct is y equals k times x. We already found the constant, actually. It's 0.2, so you could just do y equals 0.2x, or you can change your 0.2 to a fraction, which would be 1/5. So you could also have y equals 1/5 x. Okay, let's try another one. So looking at B, that's 0.5. 8 divided by 4, I know, is 2. 18 divided by 6, which is 3. So notice those are not the same. So now I need to look and see if the product is a constant. So I need to do 0.5 times 1, which is 0.5. 8 times 4, which is 32. And then 18 times 6, which is 108. Notice those are not the same either, which means there is not a either inversely proportional or directly proportional. So they don't have anything in common. There's not a constant there, so you would just write neither. Okay, so looking at C, so I'm going to have 5 divided by 1. Always start with the y. That's 5. 2.5 divided by 2, which is 1.25. 0.5 divided by 10, which is 0.05. So those are not constant. Now let's try multiplying it. So 5 times 1 is 5. 2.5 times 2 is 5. And 0.5 times 10 is also 5. So there's our constant of variation. Now, Notice it was the product. So if you look back up here, if the product of your y and your x is constant, that is the inverse. So that is y equals k over x. We know the constant is 5, so I would have y equals 5 over x for my equation. So I would write inverse here. The reason it's the opposite, some of you are probably thinking, well, we multiply it, but we're going to do inverse, which is dividing. But if you look at this equation, if you multiply to get k by itself, you're multiplying. So x times y gives us the constant, which is exactly what we did here. So that's why if you multiply it, it's inverse. If you divide it, it is direct. Okay? If you have any questions, please let me know.